Okay, continuing on with this question 1.3. Um, Gee, when I looked at it, I was looking at all sorts of different things when I first looked at this, and then I remembered something real important that they often do. They say here that they want you to prove that this side here, AG, is equal to this side AB. Now, when I first started, I was looking at this thing and thinking about a lot of different geometry to try and prove that that might be true. And then I realized, they always use the questions from before. In fact, the question that we just did, we proved that ADG is similar to AGC. And in the very first question, they played a game. I see AG happens twice here. So if we go AG goes with AC, the way that AD goes with AG, we get this fraction here. And if we cross multiply, we get AG squared is equal to AD times AC. So I remembered, oh man, we should use what we just did in the last question. Make the ratio using AG twice, and then we get AG squared. Why is that such a good idea? Because in the first question, they gave AB squared was equal to AD times AC. That's already proven, and we already proved this similarity, and then I did the ratios, and then got this AG squared thing. Hey, they're both equal. That means that AG squared equals AB squared. They both equal AD times AC. Well, if AG squared equals AB squared, if I square root both sides, I get AG equals AB. Now it's just a bit, once you see what you're supposed to do, it's easy, but it's pretty darn tricky coming up with it. Even I had to look and go, it wasn't so easy. But they use this trick more than once. I've seen it more than once, but it takes some thinking. I hope that helped that. Now, the next question is actually pretty easy. And you also remember, they say if AG is equal to 6 and AD is equal to 4, calculate DC. Well, go back here. Look, we just did this thing. AG squared equals AD times AC. All you got to do is write it down. And instead of AG, put a 6. And instead of AD, put a 4. Well, that's 36. That's 4. You divide by 4. You get your answer of AC is equal to 9 units. Now there's often a thing, the first questions are really hard, but then they give you one like this that's just substituting in numbers and really pretty easy. Sometimes they've given you the formula. They didn't here, so if you hadn't figured it out, well, they kind of told you that this was true, so you should be able to get there. But anyways, that's that question. The very last question says it's the length of GD. Find the length of GD, this GD right here, from G to D, given that CE is the diameter of the circle. So I drew a dotted line between CE and think, okay, that's a diameter. Well, that means this angle D1, it doesn't look like it in the diagram, but if that was the diameter, D1 would be 90 degrees. That's angles in a semicircle. And then I saw this straight line. If D1 was 90 degrees, angle GDA would be 90 degrees because of angles in a straight line have to add up to 180. Well, if that's a 90-degree triangle, I can use Pythagoras. And if I'm looking for a short side, it's the hypotenuse squared minus the other short side squared. That's how you'd use Pythagoras. And so DG squared equals 6 squared minus 4 squared. Then you just do it. That's 36 minus 16. That's 20. And if I square root both sides, I get the square root of 20, which is 2 root 5. My calculator tells me it's 4,47. And they like you to put units on there. They've talked about units all the way along. Okay, some of that was pretty challenging, and you might want to go over it really carefully, and even try it again yourself sometime. We'll put it away for a couple of days and come back and say, can I do this question now? It would be good practice if you did. Okay.